My name is Muhammad Hakimi bin Muhammad SOFIAN. Today I would like to talk about my functions, which is calculate elastic modulus. So, here we begin. There are 4 things I would like to talk in this video. The first one is the calculations. The second one is the input parameters. The third one is importance of the functions, and the last one is detailed side effects. Elastic modulus, also known as the modulus of elasticity or Young modulus, is a material property that describes how a material responds to deformation when subjected to an external force or stress. It is a measure of the stiffness or rigidity of a material. So, the calculated elastic modulus functions gauge the stiffness of the material under tensions or compressions by analyzing the stress to strain ratio, offering quantification of the material reactions to the applied force and deformation. The calculation for elastic modulus EY is calculated using the formula EY equals to stress over strains. The function takes in the stress, which means force over area, and divided by the strains, change in length over original length. For these functions, we have the 4 parameters, which is stress, strains, and the elastic modulus. The stress ones, this array store the calculated stress value for each sample. Stress is calculated as the force applied divided by the cross-sectional area and is measured in Newton over meter square or Pascal. And the strain, this array holds the calculated strains value for each sample. Strain is calculated as the change in length divided by the original length. And the last one is elastic modulus. This array stores the calculated elastic modulus value for each samples. Elastic modulus is computed as the ratio of the stress to strains and is measured in Newton meter square or Pascals. The importance of elastic modulus. The first one is material stiffness and deformation predictions. In engineering significance, elastic modulus measures the stiffness or rigidity of a material. It helps engineers predict how much a material will deform under applied loads and provides insights into its ability to maintain its original shapes. In the programming connections, the calculate elastic modulus functions in the provided code computes the elastic modulus for each sample. This information is essential for engineers to understand how materials respond to the stress. Move to the side effect of the elastic moduli. In the calculate elastic moduli functions, there are no significant side effects in terms of modifying global variable or external states. However, there are few considerations related to the potential behavior of the functions. The first one is division by zero. In the explanation one, with the functions assumes that the strains values are not zero for any sample. If strains is zero of any sample, it will result in a division by zero error, leading to undefined behavior or program terminations. The impact, this situation could potentially lead to runtime errors. It is advisable to ensure that the input values are valid and the denominator strains is not zero. Adding a check for zero values in the denominator would be good. The second one is no memory allocation and or deallocations. Explanations. The functions does not allocate or deallocate memory dynamically. It relies on the user to provide arrays with the sufficient memory for the calculated results. The impact, while this is a not side effect per se, it's worth noting that user should allocate arrays with size equal to or greater than the specific size to prevent the potential memory related issues. That's all from me. Thank you.